Hey everyone, welcome back to my channel. So what if I told you that a simple spreadsheet, a black and white image, and even a neural network, they all speak a same language? Would you believe it? I'm really spitting out the facts and they do speak a same language. That language is called the language of matrices. And matrices are used everywhere in the machine learning. So that's why today we are going to explore what the matrix is and why is it considered as a powerful tool in the data science and AI. So, as per the definition here, a matrix is simply a rectangular arrangement of numbers, symbols, or expression organized in rows and columns. Think of it like a table of numbers. So, I can say that there are number of elements, that is A1 to up to A1, and that is A11 up to AM1. So there are number of elements wrapped in a square bracket, and this square bracket is denoted by the capital letter A. And these elements are arranged in rows and columns. So I can say that this is the first row, this is the second row, this is the mth row. Okay, this is the first row, second row, this is the mth row. Then similarly, this is the first column, second column, this is the nth column. So this is the first column, second column, this is the nth column. So I can represent the shape of this matrix as m cross n, and the total number of elements in the matrix will be that is m multiplied by n. It will result in the total number of elements. Suppose I want to represent any element in the matrix, so I can represent it in the form of a of ij, where I is the ith row and j is the jth column. So now let me write a simple matrix here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the shape of this matrix is 3 cross 3, and the total number of elements in the matrix will be 3 multiplied by 3, that is total 9 elements. So suppose I want to represent this element 5, so I can write it as a of 2 2, so which is nothing but a value 5, the element 5. So I can say that the element 5 is located in the second row and the second column. Similarly, if I want to represent the element 8, that is I can write it as a of 3 2, that is element 8. So I can tell that this element 8 is located in the third row and the second column. So this is how we represent a matrix. Now we will study about that where do the matrices show up in the machine learning. So coming to the first point, that is representing the data. So in the most machine learning problems, the data set, okay, we will use the data set and store it as a matrix. So I can write this data set, okay. So I can write this as a matrix X represented by 1200, 3, 10, 1500, 4, 5, 1000, 2, 20. So this is a 3 cross 3 matrix, and this data set contains the features, that is these 3 columns. That is the first column, that is size, then second is bedroom, and third is the age of the house. So we will transform this data set into the form of matrix, and this matrix is used in the machine learning. Now coming to the second point, that is a black and white image. So here if you can see this image, this cell, okay, is represented by a pixel, and the pixel has a value ranging from 0 to 255. 0 means black color, 0 means black color, and 255 means white color. And the value ranging between 0 to 255 are called the shades of gray color. Now this image is represented in the form of this matrix and let call this as a matrix A. Now if you see this black area in the matrix, okay, around this grid, so here you can similarly see the value 0, okay, around this numbers greater than 0. So this value represents the black area in this image. And for example, this first cell, okay, is represented by the value 0. So this first cell, which is also denoted by a pixel, having the value of 100. Similarly for the second cell having the value of 150, then the third cell having the value of 100, and the center cell, okay, the cell in the middle of this grid is white, so its value is denoted by 255. So now this matrix is fed into the convolution neural network, which is an algorithm, okay, and when it is once it is fed into that, the algorithm will learn the pattern from this data set, and once it learns the pattern, then it will try to do variety of things. Suppose you have fed the matrix of images, okay, images of certain people, then that algorithm can figure out the facial expression from that matrix. Even it can recognize the object from that matrix. So that's where this matrix is used. Now coming to the third point, so matrix is also used in the neural network. So suppose this is my data set. So this is the data set that contains two features, okay, two input columns, that is IQ and CGPA. And for the particular combination of IQ and CGPA, the students had got the package last year. So based on this data, we are going to train a neural network. A neural network is trained so that once a new data comes, it is able to predict the package of the student. So for example, I can write this matrix as X, that is 80, that is IQ, and 8 CGPA for the first student, then 69, 75, and 127. So this matrix contains the IQ and CGPA of the students, okay, who secure the packages last year. And now this is the also called the target vector, that is the containing the LPA of those students having the IQ and CGPA. So this is like 3 LPA, 3 lakh, then 5 lakh, then 8 lakhs, then 11 lakhs. So this matrix, okay, the data from this matrix, okay, so the first row is also called the vector. So this row is fed into the neural network, this neural network. So slowly and gradually we will provide all rows to the neural network, and neural network will train on this data set, okay, that is the X matrix and the Y matrix. And once it is trained, it is able to predict the LPA of any students with IQ and CGPA. So suppose if a student with having the IQ as 90 and CGPA as is 8, okay, so it can predict the LPA. Suppose it is the 8 LPA. So this is how neural network learns the data pattern, okay, from this matrix, and it is able to predict. Now we are going to explore that why the matrices are so powerful. So coming to the first point, matrices organize data very neatly. So I have shown you the earlier example of spreadsheet. So in this spreadsheet, you can see that it contains input feature, that is size, bedroom, and age, and the rows represent the house ID. So the order of the data, okay, when the matrix is transformed, the order of the data remains same. And suppose if I change the order of the data in the matrix and I feed it to the machine learning algorithm, it will predict incorrect value. So if you are going to transform any data set into the matrix, the order should be same. Okay, so the order of the data is necessary, so it should represent the relevant info. Like here in the matrix, the first column represents size, the second column represent bedroom, the third column represent the age. Similarly, the first column row represent the house ID 1 here. So in that case I can say that the matrices organize data neatly. Then the second point is matrices make the calculation easy. So there is one example. For example, suppose you are HR of the company, and uh, there are 4 employees in the company. It is a very small company, and there are two departments in the company, that is tech department and the design department. So currently this is the data set of the employee for this month who has spent the hours in tech and design both. And the second data set represents the pay power pay per hour for the department. Okay, so the for the department they are paying 500 rupees per hour, and for the design department they are paying 400 rupees per hour. So I can transform this data set into the form of matrix. So I can write it as a equal to 120 30, then 100 40, 140 20, and 130 25. So this matrix contains, okay, total number of hours for each employees in two departments spent this month. Okay, the tech department and the design department. So the first column represents the tech number of hours for the tech department, and the second column represents the number of hours for the design department, and the row represents the each employees. Okay, the first row represents the employee name Alice, then the second row represents the employee name Bob. So now this is the data set transformed into the form of matrix, and the second data set I can write it as a b equal to 500 and 400. So this matrix contains the pay per hour of two departments, that is tech and design. Now I can say that the shape of this matrix is 4 cross 2, and the shape of this matrix is 2 cross 1. So for example, I want to calculate the total salary of each employee for this month. So for example, I pick one employee, that is Alice, and I can, if I calculate her salary, so I can write it as a 120 into 500 plus 30 into 400. So that might be around 72,000. So for example, I have to calculate the salary of each employee. In that case, I have to do the calculation for each employee. And in the future, if the number of employee increases, then this will be very tedious task. Okay, so that's where matrix comes into play, and it makes the calculation very easy. So suppose if I do like multiply both matrix A multiply by B, I can directly get the result in the resultant matrix. Suppose this is my result, and there should be a condition. Okay, if we are multiplying two matrix, so that condition is, for example, the shape of this matrix A is represented by 4 cross 2, and the shape of the matrix B is represented by 2 cross 1. So in this case, the number of columns in matrix A must be equal to the number of rows in matrix B. So this is the number of columns in matrix A is 2, and the number of rows in matrix B is also 2. So if these two data are same, okay, then in that case we can only do the multiplication with two matrix, between two matrix. And the shape of the resulting matrix, I can say that the shape of the resulting matrix will be 4 cross 1. Okay, the shape of this resulting matrix will be 4 cross 1. So I can say that this is how the matrix made the calculation very easy. Now coming to the Third point, matrices help understand the relationship. So this is the another data set. So this is the data set of the students who has spent hours studying each subject. Okay. So for example, the student A spent 3 hours studying maths, then 2 hours studying science, and 4 hours studying English. So I can write this data set as x equal to 3, 2, 4, 5, 1, 2, 4, 3, 5. So I can get a variety of insights from this data set. For example, um, I can say that student B spent more hours compared to other students in maths, science, or English. Okay, so student B spent the maximum hours, that is 5 hours, in studying maths, and least hours studying science. Okay, that is 1 hour. So I can say that I can get this type of insight from this matrix. Okay, and if I do the sum of each column, okay, that is math, science, and English. So for example, the sum of this column, that is 5 plus 4 plus 9 plus 3, that is this is 12 hours. Then for this column it is 6 hours. Then for this column it is 11 hours. So I can say that major mostly the student spends, okay, maximum number of hours in studying maths and least number of hours in studying science. So this is how metrics help us in understand the relationship. Now coming to the fourth point, matrices power image and video processing. So for example, if you are using a phone, and in the phone every image is nothing but a matrices of the pixels. Suppose you are using the camera app and you are applying the filters on the image, or you are doing zoom, or you are doing the focus. Okay, so in that case it is nothing but you are applying the mathematics on the matrices. So I can say that matrices power image and video processing, and in case of video it is nothing but a frame of images. Now coming to fifth point, matrices run all machine learning models. So whether it is a simple linear regression for predicting the house price, or a voice recognition system, it is using the matrices only. So even a neural network that powers ChatGPT and Google Translate, it is using the thousand of matrices under the hood. So I can say that matrices run all machine learning models. Now coming to the sixth point, that is matrices work perfectly with the computers, and why GPU and not CPU. So for example, suppose you are a chef in the restaurant and you are given a task to chop up the 1,000 vegetables and you have only one knife. Okay, so what you will do? You will do the chopping of the vegetables one by one. Similarly, if the CPU is given multiple tasks or a general task, it will do that step by step. But suppose you have got 1,000 assistant and they have got 1,000 knives. Okay, in that case, they will chop off the vegetables at once. So in the same way, the GPU will perform the thousand of operations on the matrices at once. So that's where we can say that matrices work perfectly with the computer and mainly on the GPU. So yeah, that's it. If this video helped you to understand the definition of matrix, then don't forget to subscribe and hit the bell icon so you don't miss the next video in the linear algebra series for the machine learning. So thanks for watching my video and see you in the next upcoming video for the matrices.